for 2 years. So I will do a quick introduction, and then I want to say something very important, and then we will start. Now, first of all, I am Miss Alderete Toy, and I am your mathematics teacher. Everything about mathematics excites me. So you are really in for a ride as we, and I like the word we, as we explore mathematics together. It's not only me, it's all of us working together in order to reach a goal. Then I want to say something, and I always think that you sometimes forget this when you're in grade 10. Not for 8 and 9, not for grade 8 and 9, but for grade 10. I just want to remind you of something very important. Being here in grade 10 mathematics in this class was a choice that you made. That is your responsibility to take ownership of the learning of mathematics. Your progress in mathematics depends on the work and the effort that you put into it. If you find any challenge along the way, there's the discussion forum, there's this class, we can all learn together and you can ask questions. I'm here to always guide you. If you commit to hard working, if you commit to walking the extra mile, this class will really put value to your future. So that was just a quick introduction and something that I really want you to remember. Before we start, I want to quickly go through our virtual classroom etiquettes, and this will always be the very first lesson of every term. I will go through this. I will not go through it every single lesson, only the first lesson. And I will rush through this as I feel that when you're in grade 10, I feel like this is part of your daily life. So you will hear me a lot of times saying being respectful. So respect for me is the most important thing. If you are a respectful person, everything else will fall into place. Respect for yourself, respect for people around you, respect for the things, your own things, taking ownership, everything else fall into place. You will be on time. You will be prepared for lessons. You will dress appropriately. You will listen carefully. So respect really cover it all. Then just something, please make sure that when you want to ask a question that you raise your hand and you don't just start talking. Otherwise, it's you and me talking. And then be on time. I already said being on time is important. You know by now, I think I might have taught some of you already last year at the end, the last 5 lessons. Please be on time because 1 minute after our time, I start teaching. So please don't be late. And then the communication in the Q&A. So you will always see that the Q&A is open. Will you please keep that questions to mathematical questions and don't answer questions that are asked during the lesson, because if you answer it in the Q&A, we will tackle them at the end. Those questions that we don't get to, I'll post on the discussion forum. But if you ask like questions about an activity or an example that we're busy with, I completely missed that question. And then the last 2 ones is just listen carefully, as I already mentioned, with being respectful. And I have so many learners, they're telling me, Ms. Alderete, how can drinking water be a virtual classroom etiquette? Can I just tell you, make sure you have your water next to you and make sure you take a sip. Water is like fuel to the brain and very good for you. Then just this quick slide again, the Q&A. Can I please ask you to that questions? It's mathematical questions, not how are you, not please do this, not like mathematical questions, so that I don't get lost in all the questions. So some of you already work through module 1, but I want to just emphasize one thing about module 1, and that's like general, I almost want to say admin. So grade 10, that is all your formal assessments for mathematics for this whole year. So in this term, you will do an investigation. I absolutely love creating that. You will get it next week. and then you will have until module 4 to complete it. At the end of module 4, you submit it. Then you also have a cycle test, and then you can check what's in term 2, what's in term 3, and what is in term 4. What I also like to do is write down the weightings. So you will see that the weighting, it counts towards your SPA at the end of the year. So you can literally already see the most weight is the investigation that you're going to do. And the investigation, some of you, if you don't know yet, an investigation is investigating something that's completely new. You've never seen it before. It's something completely new. But I always create my investigations in grade 10 and in grade 11 in a way that you don't have to do any research. Literally, the questions is like self-leading, going to take you to the next step too. So you don't need anything, you just need your paper. It's like amazing. So don't tell me, Miss, I did research. You don't have to do any research. Literally, my page guides you through the investigation. My tip is always to never go and Google something, because if you Google it, you don't learn. But if you follow my investigation, it's amazing the things you learn and the things that will stuck forever. Okay, so what we will do now is we will start with our first lesson. So here we go. We have like 50 minutes and we're going to start. If at any time you have a question, you're more than welcome to raise your hand and ask any questions. Sometimes I will like, oh, that's not a math question. Let's move on to the next one. But please remember, you're more than welcome. So just to give you a quick overview of what every single lesson will look like. So when you come into class, grade 10, this is what you can expect. We will do a hook, like I'm going to capture your attention, make you curious for the lesson, make you wonder, make you like that's like, I want to have your attention. I will always do that first. Then I will do like a quick, my hook is normally like an activity that gets you interested for the things that's coming, but also for things that already happened. So I link the two, and then I will just tell you what we will do in the lesson. And then we will do new content. So the new content is a large chunk of the lesson where we will do questions together. I will ask you to do things on your own. And then the last one is just a 10-minute quick recap. And then that one question that I'm always going to ask you to do. Today we actually have 5, but they're quick ones. We can do them just orally. So let's get started. 1, 2, 3, 4. I hope you are ready, because I now want you to think, and I want you to raise your hand and give your opinion. So this is our first, like the hook, or the brain break, or the brain teaser, or the challenge. Here we go. Is 0,999 recurring? So that 9, please listen carefully. That 9 is recurring, like going on forever. There's different ways we write them. So I just quickly want to show you something. I already see a hand, so I'm super excited. I just want to get my pen color correct. So I just want to show you. Oh, wait. Okay. So I get very excited when I'm doing math. Just a quick something else. I have a 4-year-old, and I think because he's hearing math like 8 hours a day, because he's not in school, he's going to school this year. He asked for a gift over the December holiday. He wants a math book. So I actually did bought him a math book. So if you see me getting excited about math, I really love math. Okay, so 0.999. A lot of times, grade 10s, I want to tell you, I'm going to show you something, and Yendi will tell me, but Miss Alderete, this is not even like in our syllabus. Please remember, sometimes I will show you things that's like you will use in the future. I want to get you curious for the future. So please, if you see anything like it's very weird, you're like, Miss Alderete, seriously, what's the E? But yes, please know that. But I want to show you something. So in math, if we write a recurring decimal, you can write it as 0.999. And a lot of times people will make like 3 little dots. A different way of writing a recurring decimal is, for example, 0,9, and that 9 they put a little dot on. The other way they do it is they say 0,9, and they write a little bar on top. So it doesn't matter. Like in our online campus, we use, for example, the dot on top, or we use a comma, not the comma, the dots. But in other textbooks, they might use the bar. Online, they might use the bar. So please make sure that you are fully communicated like in a math, and that you can communicate this in all the different ways. I want to show you something else just to make sure that you get the hang of it. Say, for example, it's 0.2, but it's only the 5 that's recurring, only the 5 recurring. Then that little dot will only be on the 5, or the bar will only be on the 5. Just to give you an example of maybe when you get to the textbooks. And it looks a little different. Okay, so we have our very first question. Is 0.999, remember it's recurring. It's recurring. It's not 0.99, because then this question will look totally different. It's 0.9999 and continuing forever. Is that equal to 1? And the question is, yes, it's exactly equal, or no, it's just a tiny bit less. And can I say, I did this question with so many adults, and they like, no, Audrey, you're breaking our brain. Just next question. But I love this question because it completely links to what we're going to do today. So I'm going to ask the first learner that hands is up. I want to ask you to tell us. And if I ever pronounce your name incorrectly, I in advance ask for an apology. But Zahar, you first, so you can give us your answer.
Hi, ma'am. Can you hear me?
Clearly.
Okay, my name is actually Sahar, so it's like with an S. Sahar. My answer is B. It is a tiny bit less, but I think it can be rounded off to 1.
Okay, good. I don't want to tell you you're wrong, but I'm going to dive a little deeper into this. And then I'm going to ask the next person, Koketsu, what do you think? Koketsu, what do you think? Okay, Koketsu, I'm going to jump to the next learner. Fila, what do you think?
I think it's B, ma'am.
You also think it's B, so we have 2 learners saying B.
Well, yeah.
Can I ask something? Anyone thinking it's A, like it's exactly equal? Tuan, are you thinking? Okay, I see like he's like excited, Miss Alderette. I'm going with A. Maybe you're just going with A because everyone else is going for B. Okay, but okay, let me tell you this. It's such an amazing question. And I'm going, if some of you are sitting here and you're like, Miss Alderette, seriously, what's the answer? I'm going to show you now. It is very amazing. So actually, it is exactly equal to 1. The answer is A. And the trick here was, maybe what I think was the little trick was, I didn't ask 0.999. I asked 0.9 recurring, like it will never, ever, ever stop. Like that's what I asked. So if you still struggle, think about the following. Can you find a number between 1 and 2? Think in your head, can you find a number between 1 and 2? Okay, so I'm going to ask you, can you find a number between 1 and 2? Ketsu doesn't want to talk to me. Daniel, you next.
Hello?
A number between 1 and 2. Yes, Daniel, you can.
Are we allowed to use like rational and irrational numbers?
Fine, you can.
So 3/4 then.
Perfect. Okay. So you can find a number between 1 and 2. But great thing, if I tell you 0.999 recurring and and the number 1, there's nothing in between them. Therefore, it can be exactly equal to 1. So what we're going to do today is we're going to look at how to make recurring decimals. Remember, the trick here is recurring decimals, not terminating, recurring decimals. Today we're going to look at how to make recurring decimals into a fraction. And that's actually how we do it, but we will not look at this example. We will look at a different example. So that was our hook, like to get your attention. So I hope all 396 of you are now ready for our lesson. Like now I want to know. First of all, our mission for today, we will do 3 things. We will convert recurring decimals. I'm saying recurring because I'm scared you think it's a terminating. It's a recurring, going on forever, like never ever stop. We're going to change that into a fraction. It's also an exam skill or a formal assessment skill that you need because we're going to do that in a question paper or exam. The next thing, we're going to define between rational and irrational. And I absolutely love how Daniel mentioned that. So linking math, nice math everywhere around the world. And then the last one is just a tricky classifying numbers, the tricky square root of 9. Like, is that a rational or irrational, or the pi? So I just want you to not make a mistake with that, therefore I added there. Okay, so that is our mission for today. So now let's start with our new content. So what I'm going to do is, before I start, I'm just going to ask the 3 hands that's up. I'm going to ask you your question. I feel like I can't speak English anymore. The holiday was way too long. And then we will do an example that is easy, and then we will progress to a little bit more advanced. So before we do this question all together, CBCC, where do you have a question? Okay, so you can lower your hand. Kelsey, do you have a question?
Yes, ma'am. Hi. I wanted to ask, so I also agree that the answer in between the number between 1 and 2 is 3/4, but I'm a bit confused on how that's the answer. So how did we discover that?
2/3. 2/3.
Oh, 2/3. Okay. Thank you, ma'am.
Okay. Are you okay, Kelsey?
Oh, yes, ma'am. Sorry, I just heard the number wrong. That's why I was confused.
I don't know, great dance. Kelsey, 2/3. I don't know if you ever watched that video when lockdown started. There was this guy, now I can't remember his name. He was in the news, and he had a conversation with someone over the internet like we do now. And then the person, like the nanny, coming in, and then the kids are coming in, and then the nanny come crawling in and grabbing the kids at the feet and going on. That was literally me now. I mute myself. I'm like, and chasing all 3 of them out. They're not in school yet, so their school starts tomorrow, and then the other 2 schools starts on Thursday. So they're still here. And the moment they hear me talk, never come into my office, but let me talk or let me teach. They're like, Mommy, can we have cookies? Mommy, we're hungry. They're always hungry. Kids are always hungry. Always. How's it possible? But yes. Okay, Umfile, your question.
Hi, ma'am. Sorry to take you a little bit backwards, but I wanted to ask, since the answer for the first example you gave us was exactly the same, would we be correct if on the exam we wrote it's the same because there is no number between 0.999 and 1, so it's exactly the same?
100% correct. I will never ask you a question like that in the exam, never ever. I always say never ever, but people, like I don't sit the end of year exams in grade 12. So maybe someone can ask you, maybe someone can in grade 12. But for now, we will not, but your answer to that question is 100% correct. And that's why we're actually doing what we're doing now. This activity in front of you, that's actually what we're doing. We're proving why 0.999 recurring, not 999 recurring is exactly equal to 1. Tuan, your question. Tuan?
Hello, teach. I have a question between, like you said, find a number between 1 and 2, and it was 2.3. They're like 2 over 3. Would it work if if it was 1.5?
Not
Would that also
1.5.
work?
So
1.5.
yes, it can be 1.5 as well. You are correct. You are correct. Oh
So
wait,
that is also a valid answer.
wait a minute. Wait a minute. Let me write it out. Give me a second. Give me a second. Now I know what Kelsey was asking. So I asked, what's the number between, sorry, I will erase this now, between 1 and 2, okay? So the number between 1 and 2 is indeed 3 over 2. Apologies. It was 3, Kelsey, 3 over 2, because 3 over 2 is 1.5, and 1.5 is between 1 and 2. So it's not 2 over 3. Apology, my mistake. Okay, Kelsey, that's why you're confusing. Tuan, are you good?
Yes, thank you.
Okay, thank you for correcting the math teacher there. I can make mistakes. Okay, so we will now do this question together. Now, like I said, some of you will be like, Ms. Alderet, you're giving us such an easy one to do. But please remember, my next slide, look at that, a little bit more challenging. And then my slide way at the end with our exam time type of question, a little bit more advanced, because that's why math is so beautiful, because we can make things like super, super interesting, not difficult. Please don't use the word difficult. Okay, so I'm now going to show you how to take a recurring decimal. And remember, we can say 0.2 with, and then there's a little dot on top. And remember, we can also write it like that with a bar or with the 3 little dots. I will say that a little, and then from next week, I don't mention that anymore. So we're going to take that recurring decimal and we're going to change that into a fraction. Now, what I'm going to do now, before I'm going to start explaining this, I'm quickly going to open a poll. I will start easy with the polls, but I love the polls and I sometimes use them in lessons. So what I'm going to ask you a question. Is the answer... Now I need to have like nice things. Okay. I'm going to launch my question. Launch. So I have 2 questions, or I have 1 question. Is the answer 2 over 7? Or is the answer 2 over 9? Try not to use your calculator. Try not to use your calculator. And if you can't find the polls on your computer, use this example for a practice session. We all learn together. Okay, I see a few answers for 2 over 9. I do see a few answers. Okay, so what I did, and also on the online campus, your online textbook. So we don't have a hard copy textbook, even though I have a lot of hard copies books I love. But we use our online one. And on that online campus, I also outlined the steps. And the nice thing about the steps or the guides or whatever you like to call them, they work for any recurring decimal taking into a fraction, for all of them. The only thing that is changed is this one here, where we multiply by 10, by 100 or 1,000. But in my next slide, I will make it more advanced. So let's just start easy. Okay. First of all, I have a question before we just start. The 0.22222, how many numbers are recurring? How many are recurring? How many are recurring? Marco, go.
It's quite difficult to tell because there's a dot on the last one, which indicates that it goes on forever.
Yes. So which one is recurring?
Which I see, it appears to be 3 that are recurring.
Okay, so it's 3, but please remember it's the 2 that is recurring the whole time. So 2 is the same number. So there's only one number that's recurring, and that's the 2. Okay. So, but Marco, I like what you think, and I like how you work with this. So let me show you something. So if it's only the 2 that's recurring, we do the following. And I will show you 3 different examples. The very first step that you do, and I wrote it out here and I will also write it here. The first thing that you do is, any pens, Mama, class. No, you can't. So the very first thing you always do is you say the following. You make x is equal to the recurring value. Now, whether you write 2, 2, 2 and make dots, or whether you make a dot on top or a bar on top, it's all the same. You will see that I write it as the 3 dots, and I will explain to you why, because then it's easier for me to just eliminate them. So that's the very first step. Then the next step is to multiply it by 10. Now, in my next slide, I will show you when to multiply by 100 and when to multiply by 1,000. And then the next thing, we will multiply by 10. Now, in math, when I tell you here to multiply by 10, we do it for both the left and the right side, not only for one side, because whatever you do on one side, you always have to do the same on the other side. So I'm going to multiply both sides by 10. So x times, apologies. I need to just in time because she's shouting. Okay, so what you're going to do is you're going to take the left side and you multiply it by 10, and you're going to take the right side and multiply it by 10, because we multiply with the equation straight through. So some learners will write it like this. They will write multiply by 10, multiply by 10. But grade 10, this is mathematics. You can also do it like this, multiply straight through by 10. So it depends on the way how you like to write it. Just make sure that it's making logically sense for the person marking your work. Okay, so I'm going to multiply both sides by 10. So x times 10 is 10x. And then 0.222 recurring, multiply by 10, my comma move 1. So this becomes 2, 2, 2, 2, and I like the dots, okay? So we're done with step 1, where we make the recurring decimal equal to x. We're done with step 2 by multiplying by 10, and I will show you when to multiply by 100 and 1,000, or sometimes both. And then the last one, the subtracting part. Now here, we're going to take this equation. Now this is our equation number 2, and that is our equation number 1. So we're going to take 2 and we're going to subtract 1 from it. So I'm going to write that and leave it there for those of you who are going to look at the slides later. So 10x times x is 9x. And because they like terms, I can subtract them from each other. Like term is also a word that you will hear very often. Then this one, 0.222, I'm going to subtract that from 2.222. Now, why I like to make the exact same, and I'm going to use red here, why I like to write the exact same recurring decimals is because I can then easily cancel them out. So 2.222 minus 0.222 is then that 2, and I will leave that red, and then from here on, last step, just solve x, and the inverse operation of multiplying on my one side is divide on the other side. Okay, so now I will take up all the questions. Sibosiwe, you are first.
Hi, ma'am. I wanted to ask, on the step where you are canceling out, because I get from when you added the 10x, it makes sense, which means you shift the decimal, I mean the points or the comma, and then, ma'am, why did you cancel out with the top one?
Okay, let me show you.
Instead of canceling it out from the, when you did -1 from the 10, you didn't do -1 on the other end.
Okay, suppose you see where you can do that. You can say 1x minus 10x, then it's minus 9x, and you can do the same on the other side, and then you will have two negatives, and the two negatives will also cancel each other out. So it doesn't matter which way you do it. So whether you say equation 2 minus 1 or 1 minus 2, you will get the same answers. So you take 10x minus that x, which is 9x. That's the first one, and I'm quickly going to erase that. And then the other one is the 2,222 minus 0,222. So that 2's cancel each other out. So I'm left with the 2. Is that helpful?
Yes, ma'am. Thank you.
Okay, great. Kungati?
Ma'am, I just wanted to ask, before we move on to the next example, may you please start over? Like, I got confused by step 2.
By step 2, where you multiplied.
Yes, ma'am. Like
Okay, so we multiply by 10. So that's our step 2. So I will quickly show you, for those of you who are curious, how did I know to multiply this one by 10? And why not by 100? And why not by 1,000? So let me show you. If the recurring decimal is only one number recurring, like the 222 here, then we multiply by 10. If it's 0.121212 2 are repeating, so we will multiply by 100. When do we multiply by 1,000? When we have, for example, 1.125, 125, 125, 3 numbers recurring, then we will multiply by 1,000. Because multiplying by 10, multiplying by 100, and multiply by 1,000 make it able to cancel out, I almost want to say, the decimals. Okay, Kungati, you good?
Thank you so much.
Okay, Bianca, you are next. You can ask your question.
Can you hear me?
Clearly.
Ma'am, I don't understand, like I generally don't understand the whole thing. Is it possible if you can redo it for me, please? Because I don't understand.
Okay, so the very first step, okay, also remember that grade 10, by now you should have done this lesson, okay? So we are on Tuesday and you already should have worked for lesson 1. So this is normally like a quick recap. And so let's quickly go through this again. The very first step, also outlined in the online campus, is making the recurring decimal. Whatever is the question, the recurring decimal, make it equal to x. That's your first step, okay? So that's where I make that x equal to my recurring decimal. Then from there on, I either multiply by 10, 100, or 1,000. And I already explained when to multiply by each. So literally what I did, I multiplied both my left-hand side and my right-hand side by 10. And that's what I did here, and I got the answer. The next one, I subtract them from each other. So that is like one equation, that x is equal to 0.222. That's my one equation, that one there. And this is my other one. I subtract them from each other. Now, whether you subtract the bottom one from the top one or the top one from the bottom one, your answer will exactly be the same. So don't think it will not be. What I just like doing, I like to say 10x minus x, then I have a 9. But if I say x minus 10, I get negative 9, and then I have to sort out my negatives later. So that's why I just love working with the positives. And then the last one is just solving your x. So that's the 4 steps we have here. Did that help?
Yes, ma'am. Thank you.
Okay. Uluratu, your question.
Ma'am, can you hear me?
Yes, I can hear you clearly.
Okay. Ma'am, I got confused by step 3 where we subtract. I don't understand at all.
Okay, so let's quickly look at this. We have, just want to get my pen. So we have 10, I'm going to take random numbers. So we have 8x is equal to 0.22. And we have, and I'm going to take random numbers just to show you something. And that's x minus 1.22. So if you look at this, you literally subtract, you can do the following. You can say 8x minus 7x, and you will get 1x, okay? Or 0.222 minus 1.22. It's a normal subtraction. So whether you take the top minus the bottom or the bottom minus the top, your answer at the end will be exactly the same as ours. I'm just taking my bigger number. So what I'm just doing is I'm just taking the 10x, and I subtract the x to work with positives and not with negatives. So here you have, and I want to quickly get my cursor, I'm taking 10x minus my x, and I get 9x, and 2,999 minus 0.222, and that will give me 2. Okay, I see I erased by accident, I erased one of my little 2's there. So that's purely subtracting two equations from each other. Olorate, are you good?
Yes, ma'am.
Okay. Sibo Sisiwe, do you have another question?
Yes, ma'am. Ma'am, based on the multiplier,
Yes.
you specifically used 10 as a multiplier.
Yes.
So what I looked at was I also did it with 1,000, as you were saying earlier on, and it still gave you the same answer. So if it's a reoccurring thing, decimal, it will still give you an answer no matter if you're multiplying it with the tens, hundreds, or thousands.
Yes, Sibo Sisiwe, you are 100% correct, but I'm quickly going to go to my next slide. If you look at this one here, if you look at that one, 0.24242424, you can't use 10, it will not work. But for this previous one, it doesn't matter which one you actually use, you will still get the same answer. But don't use 100,000 because the first one is 10, so you can use it because there's one number recurring. If it was 2, you use 100, then 10 will not work and 1,000 will not work. So for this one, it will work. It's like a tricky thing. For this one, it will work, but not for the other two. So that's why I'm a little scared to tell you, no, test all 3, but don't test all 3. Get into the habit of 1 recurring number, 10. 2 recurring numbers, 100. 4 recurring, 3, and we can go on to 4, but we never do 4 at school level. But Sibo Sisiwe, I'm so proud of you for spotting that. That's amazing. Well done for that. Onwaba, your question.
Good afternoon, ma'am.
Good afternoon.
Ma'am, I just wanted to ask, as for the recurring decimals and the multiplier, do we add another 0 every time there's a different number in the recurring decimals?
Wait, what 0?
No, I mean since if it's one number recurring, it's 10, and if it's two different numbers, it's 100. Do we do the same for every time there's say 4 different recurring numbers or 5 different recurring numbers?
Yes. So you're adding a 0 for everyone. So if there's 1 repeating, but now there's 2, you're adding 1. So I understand your question. Yes. Zara?
Good morning, ma'am.
Good morning.
Ma'am, I have a question with step 3, just for understanding, because I might have gotten lost. So with step 3, right, you should subtract the left side with the left side that's on top of it with step 2 or step 1, and the same happens on the right side.
Yes. So what I'm going to do is I'm quickly going to show you this again, but I want to use a different color. I actually should go to the next page because my page is getting very small. I'm just quickly going to rewrite them. So that is x is equal to 0.2, and I'm going to make I like to do that, but you can make a dot there, it doesn't matter. And then I did multiply it by 10, so that's 2.222. Okay, so you take the top one. So what we normally do and what you will see in question papers, you will see that they refer to that as a equation 1, and that is equation 2, just to make explanation better. Otherwise, I will use top and bottom equation. But when I label them a 1 and a 2, I talk about equation 1 and equation 2. So, Zara, whether you say 10 minus x will be 9x, I just like my line there, and then 2.222 minus 0.2 will give you 2. You will get x is equal to 2 over 9. So whether you take equation number 2 and subtract 1, or take 1 and subtract 2, you will get the same answer. Or whether you say top equation, bottom equation, it doesn't matter. But I just want to show you the difference. So if you say x minus 10, you will get, whenever you say x minus 10, you will get minus 9x. I just want to show you why different ways will work. Doesn't matter. And then the other way around, if you take 0.222 and you subtract 2, you will get the answer as negative 2. And then the inverse operation of multiply is divide, and a negative 2 divide by a negative 9. A negative divided by a negative will give you a positive. So for this one, if you subtract the smaller from the bigger, it will work out as a nice equation. But if you do it the other way around, you will have like a little extra step, which is not incorrect. It's just an extra step. Zara, are you good? Okay, so it doesn't matter. I'm just going to erase. I don't want to erase the important stuff. Okay, so it doesn't matter which one you do. Whether you take equation 1 from 2 or 2 from 1, you will get the same answer. And if you don't want to label it and you talk about top equation and bottom equation, it's also fine. Masego, your question.
Hi, ma'am. I actually have 2 questions. So basically, you know, like the symbols for reoccurring numbers, right? It's like the 3 dots or the line or whatever, right? But like let's say you use the 3 dots, but there's like multiple different numbers, like for example 0, 1, 2, 3, right? Dot dot dot. Like how will we know which number is reoccurring?
We will always tell you. We will always tell you. So sometimes it will be like impossible to not spot it. So we can write it like this, for example, 0.12. If the dot is, oh, that looks like a dot. If the dot is only on the 2, it's only the 2 recurring.
Okay.
Right? If the dot is on both of them recurs.
Oh, so you can't use dot dot dot.
Like, no, you can't. So if it's like this, like this, you can use dot dot dot. It will actually work and it makes mathematically sense. But if it's like this, you can also use dot dot dot. It will work for both. Perfect. It will work for both.
Oh, okay.
And you also will use something like this. This is not a recurring decimal, so no, don't worry about that.
Oh, okay. Thank you, ma'am. Also, my second question. For step 2, right, you said multiply by 10, and then you also mentioned that you can multiply by 100,000 and 10,000 or like whatever number, right? How will we know? Because like, I'm sorry, I missed that.
No, it's fine. So I'm going to quickly go to my next slide. So here you see 1.24. The 2, 4, 2, 4, 2, 4, 2 for recurring. So it's 2 numbers after the decimal that's recurring. So you will multiply by 100.
Oh, okay.
If it's, for example, I should actually change the slide to, because if I write on white, I don't see, or it's difficult with my cursors. And if it's like, for example, 5,189, 189, 189, it's 1, 2, 3, 0, so it's multiplied by 1,000.
Oh, okay. Thank you so much, ma'am.
Okay, great. Masego, I'm done with you. Kelsey, your question.
Hi, ma'am. So mine's more on so like on the question. So it said convert 0.2 to a fraction in its simplest form. So I wanted to ask, how were we able to write 0.2? How would, I'm gonna try and find a way to make this make sense, but like, how did we know that there was going to be 3 2s after the decimal sign, as in when we were doing the equation, and not more than 3?
Can you repeat your question again?
Sure. So, let me ask it this way. Does it matter the amount of 2s in your equation? you write after the decimal point, or
Not at all. So I absolutely love that you're asking it. So the reason why I see, and now I'm writing with white and then I can't see it on my slides. I love that you asked this question. So why do I miss all the red? And I'm going to erase this, and I'm also going to erase that 1 and 2 because there's too much writing going on here. Whether you write a 2 and you make a dot on top or a bar, remember you can do both, or whether you do it like me, 2, 2, and you put 3 little dots just to show that it's continue, it's the same thing. So you might ask, okay, Ms. Aldred, but why do you make it 2, 2, 2? I think it's just a habit of doing it. But the reason why I like to have after my decimal the same number that's repeat, like the 2, 2, 2, is because I can clearly see that it cancels out because it's the same. So some of you that's going to do this, if you make a 2 with a bar on top or a 2 with a bar on top, for you, it's fine. You can just see, okay, they're recurring, they're the same, they can erase. So it doesn't matter whether you write a dot on top, whether you write a bar on top, or whether you make it a 2, 2, 2. The reason why I actually love to make it a 2, 2, and then little dots is when it's getting a little bit more advanced, and I'm quickly going to go to my next slide. When it's a little bit more advanced, it's nice to start spotting the repeats if you write it out like that and easily see that if I repeat it 2 times in my mind, I can cancel them out. But again, if you use the dot on top or the bar, it's the same, so they just cancel out. Kelsey, does that explain it for you?
Yes, ma'am. Thank you so much.
That's why I always say, math is not like stick and stones. Like, there's not like one way to do it, and if you don't do it like this, you're wrong. There's so many different ways of doing it as long as your communication is clear and follow a logical approach. That's what my tip is always. So, are your question?
Hi, ma'am. So I was just wondering, when I went through the worked examples in the modules, for some of the examples, they said that you did not need to multiply. How do we know if we need to multiply and if we don't?
So if you're changing a recurring decimal to a fraction, you will always have to multiply by 10, 100, 1,000, sometimes both. But it depends on the question. If it's just a normal, like taking 0.2, nothing recurs, then you don't have to multiply. You always multiply by 10. I almost want to say, because that's how you make it a fraction. But it's only when it's not a recurring. But please remember, we're working with like recurring decimals, like something that's going on until infinity and further. Okay, next question, Malahoganye.
Good morning, ma'am.
Good morning.
Ma'am, in the test, like, how many marks will this be? This question
3, 4 marks. 3, 4 marks, depending on the difficulty.
Okay, ma'am. Thank you, ma'am.
Okay. So what we can do is, I don't see any more hands. So we have an example. The previous example we did where there was only one recurring. So our next example is one where there's 2 numbers recurring. But you follow the exact same steps. Some of you will be, okay, so Ms. Andre, your previous slide only had 4 steps. Why is there an extra one here? It's because this one actually didn't work out as like a fraction in simplest form. So that was that little extra. Remember to always simplify fractions. But the same method follows. So your very first thing will always be to make x equal to the recurring decimal. From there on, if needed, I say if needed, because if it's not recurring decimal, you will not be. You multiply by either 10, 100, or 1,000. Because there's 2 decimals recurring here, 2, 4, 2, 4, 2, 4, and going on, we're going to multiply by 100. So that's exactly what I did here in my step number 3. That's why also some of you will be like, okay, Ms. Aldred, this step 2 and 3 in the previous question, you did it all at once. Yes, I did, but here I put the extra step just to explain it. So here I multiply by 100 on both the left and the right hand side. Then the same. Subtract the two from each other, whether you take the top one from the bottom one or the bottom one from the top one or equation 1 from 2 and 2 from 1, you will get the same answer. If you just have negative over negative, it will result in being a positive. So there's that extra simplification step. And then you subtract them and you solve x. The reason why I have an extra step here is, oops, that 123 over 99 wasn't simplest form, but your calculator will show you this. So that's why just there's like a little extra step. Okay, so you can go and practice one where there's 2 recurring and 3 recurring, and then I'm going to give you all a challenge before the class end. Rational and irrational numbers. In your lesson, you would have seen rational and irrational numbers, and some of you already, you're like, Ms. Alderate, we did this in grade 9. Why are we doing it again? We literally just going to recap this, and reason we're recapping is because learners make silly mistake with this. I will never say like it's a not, I don't understand. It's silly mistakes. So I just want to recap this. Remember, in our real number system, we have rational and irrational. I know under rational, there's integers, there's whole numbers, and there's natural numbers, but we're working with rational and irrational. I want to just quickly give you a tip. The difference between these two. Rational numbers, you can always write as a fraction. That's a rational number. Please remember, a rational number is also a terminating decimal, like 1.2 is a rational number. If a decimal is recurring, it's also rational. Now, some of you might ask him, Ms. Alderate, what is irrational then? Irrational is all that coated numbers, like, oh, I can't make sense of the pattern after the decimal. That is your irrational numbers. That's your after the comma, you can't make sense. You can't even write that number in a fraction. It's impossible. You can't do it. So the moment you can write a number as a fraction, so it's literally any integer, any whole number over 1, it's irrational. But if you can't, it's irrational. What did I want to say here? Oh, I think about my son, which is telling me, Mama, this pattern doesn't make sense. So if the pattern after the comma doesn't make sense, it's irrational. Well, how I explained it when I was still teaching Afrikaans, learners like, Ms. Alderate, I never understand this rational and irrational. I told them the irrational irritates you because you can't figure out the pattern after the decimal. So it's irritating you. And you will not know how many learners make a mistake with that. Lila, do you want to tell us how you remember this?
Can I speak?
Yes, you can. I hear you clearly.
Okay, so I just want to see if I'm understanding this correctly. So a rational number is like the recurring ones, and then the irrational ones are like pi. So they don't have a end at all. Well, they just don't repeat.
They never, you figure out the pattern. So if you put pi in your calculator, the pattern afterwards, the numbers doesn't have a pattern. There's no, like, you can't figure out. That is irrational. It's also like square root of 2 and square root like 7s. It's impossible to even write it as a fraction. So you're 100% correct. Well done. Sebo, your question.
Ma'am, I just wanted to ask, back on the slide when it comes to recurring numbers,
yes.
Isn't it like the slide before this one with the 2 and the 4, which are both recurring? I just had like a question. Let's say here, instead of it being 2, 4, 2, 4, because like in a way it kind of looks like 24 is repeating itself right after the other. What if it was like 300, 200, and 300, 200, like they go like that, but how when you want to say that the 200 and the 300 are recurring, will you just put the dot on the 2, then the dot on the 3? So like, you're not putting it on the zeros as well, because it's just the pattern over and over, like 200, 300, 200, 300, 200, 300, all the way. Like, I was just asking, will they skip gaps, like make gaps in between because the number is bigger?
No ways. That is not a recurring decimal. That's not a recurring decimal. Then it's not. So it needs to be a recurring decimal. So you can get something like this, 0.111222. Then the 2 is recurring. The 2 is recurring. The 2 is going on forever. I don't have to make it there. I can already make it there. So that's possible. But not 0.0010001. No, that will not be. That number is not a recurring. So it should be a recurring decimal. That's the rule. I hope you are good. I love the sound there in CVCC.
Hi, ma'am. When we go back to the rational numbers and irrational numbers, so on irrational, your notes say the decimal goes on forever but never repeats a pattern. Is that meaning more of as a recurring decimal? Ma'am? Oh.
So please remember, it's a number that it's going on forever, but there's no pattern to it. Please remember, if it's terminating like 0.125, it's rational. If it's stopped, like terminating, it's rational. But if it's like, for example, 1 point and afterwards it's 1579223, there's no pattern, it's irrational.
Oh, so ma'am, if it's like the pi decimal.
Yes, it's the pi, square root of 2, square root of 11, anything that you can't write as a fraction.
Okay, thank you very much.
Okay, we have 2 more questions, but we need to jump before we have to go to another lesson. I just quickly want to do something. I'm going to send you out the slide. You will see that some slides we didn't get to, but it's fine. It's just a wrap up. Those of you are up for a challenge. I want you to try out this one. If you're up for a challenge, try it out and post it on the discussion forum. It's just a nice challenge. It's not homework. If you don't get to it, it's also fine. You all should have a wonderful day. I still see 2 more hands. You're more than welcome to put your questions on the discussion forum. You all should have a wonderful day.
Bye, ma'am.
Bye, everyone. I'm going to
Bye,
change
ma'am.
so that I'm not mama anymore.
Bye, ma'am.
Bye,
Bye,
bye.
ma'am.
Bye-bye.
Bye, mom.
Bye, ma'am.
Bye, ma'am.
Give those kids a lick.
Bye,
slap.
ma'am.